Hi guys, Ben here from FurtherYourMaths. Follow us on Twitter at FurtherYourMath. Now today I'm going to be working on a topic that has come up in every specimen and example paper that AQA provides us with, and came up in both exam papers in June this year, so it's pretty essential to know. However, it's also one of the most difficult topics on this qualification, one of the ones that students struggle most with, and it's differentiation. So let's start off by finding out what differentiation is. If I had a quadratic graph, it would look something like this. If I picked any point on that graph, say for example this one, what differentiation would do would allow me to find the gradient of the tangent for that point. So if I drew the tangent here, go through my point just like a tangent would, what differentiating would do is allow me to find the gradient of this blue line of the tangent. So how do we write differentiation? Like this. If an exam question says find dy by dx, what it means is differentiate. So let's start off with an example. Y equals x squared plus 5x plus 4. Now, what we need to find out is dy by dx and what it equals. So, to find this, what I do is I take this number, the start of the x squared. If I start off with x squared, we find out the number that the x is to the power of, which is 2. And we times by the number at the front, which in this case would be 1, you just don't write it. So 2 times 1 is 2. And then we take this 2 here, and we take away 1, so it then becomes x to the power of 1, which just be 2x. Now if we take our next example, what we have here is 5x to the power of 1, if we write the 1 in there. Now what we do is we do the same thing before, we take the 1 that the x to the power 2 times by the number at the front, which equals 5. Then what we do is we take away 1 from the number that's power 2, 1 take away 1 is 0, so it'll be 5 times x to the power of 0, which just be 5. And then the 4 on the end has no x to it, so we can't times it by the number that's the x is to the power of. So therefore we just ignore it. We just ignore this number here. And this is what we have. dy by dx equals 2x plus 5. Now what this means is if we picked any point on this graph and then found the tangent to that point, the gradient of that tangent would be this. So now say we substitute a value in. So say we've got this graph here of x squared plus 5x plus 4. We then pick the point x equals 3. So we can substitute it in. So 2 times 3 plus 5. And then that would then equal 6 plus 5, which equals 11. So now the graph would look something like this. So if we then pick the point 3, which would be around about here, and then picked, it'd be around about sort of here-ish, and then drew a tangent to that line, which looks something like that, except touching the graph, but it would look like that. The gradient of that tangent would be 11, as we just worked out. So that's what differentiation does. Now let's try another example. Here we have y equals x cubed plus 4x squared plus 3x plus 5. Now as you can see, this would make a cubic graph. You're more likely in the exam to be asked about to differentiate a cubic equation. So let's try that. Obviously we've got dy over dx. So now we take the number start with the x cubed, we take the number that's to the power of times by the number at the front. 3 times 1 is 3, we get 3. Take away 1 from the 3 that it's to the power of, which would give us x to the power of 2. So 3x squared. Then we take the next one. We take the number that's to the power 2 times by the number at the front. So 2 times 4 is 8. And then we do this number that's to the power of, take away 1, which is just 1. So you get 8x to the power of 1, which can also be written as 8x. Then we take the 3x, which obviously is the power of 1. We do the 1 times the 3, which is 3. And because it's only to the power of 1, if you took away 1, it would be x to the power of 0. So we just left with 3. And we ignore the number at the end, there's no x on it. So there we have it. Divided by dx is 3x squared plus 8x plus 3. And we can do what we did before, we can substitute numbers in, so if you wanted to find the gradient of the tangent to the point x equals 7, we can substitute 7 in and find the gradient at that point. Now, let's try a slightly more difficult question. This may look more complicated, but actually it's just combining what you already know. So if we combine our knowledge of expanding brackets, we can use a FOIL method. So let's start off by doing the first ones. So if you times the first ones, we're expanding these brackets. If you times the first ones, 3x times x equals 3x squared. In the FOIL, O is next, which is outer. So do the two outer numbers. 3x times minus 1 is minus 3x. Then FOIL do inner, so we do the inner 2. 2 times x is 2x, we do plus 2x. And then we do the last ones. So that would be this one times that one. And 2 times minus 1 is minus 2. So now what we have here is the same as we had before. If we simplify it down, we just get 3x squared minus x minus 2. Now we just do exactly what we did before to find dy by dx. So we do dy divided by dx equals, should do 2 to the power of times the 3 at the front, which is 6. Then we do 2 take away 1, which is 1, so it'll be 6x to the power of 1, which can be written as 6x. Then we've got 1x here, and then to the power of 1, so 1 times 1 is 1, and then take away 1, so then you've got minus 1. And because the x is only to the power of 1, if you took away 1 from that, you get x to the power of 0, so it would just leave minus 1. So if you took any point on the graph y equals bracket 3x plus 2, close bracket, open bracket, 3x minus 1, sorry, x minus 1. If you took the tangent to that point, it would have the gradient 6x minus 1. And you can do the same as what you did before and substitute numbers in to the value of x. Now, thank you very much for watching. We'll be doing another video on finding stationary points and the normal to the tangent. So stay tuned for that, and good luck with differentiating.